one customers. Okay, so you can just imagine like this. So whichever that I exchange to the customers, then the customer will inter-exchange between them and send back into their AS information. Okay, that is how the option A it works. So as long as you just configure two MPLS, the traditional MPLS BGP and in between, this is just communicate using the eBGP. Okay, between the ASVR to another ASVR, they'll just communicate through the eBGP. So whichever route that I receive, I will share to you on these directions, and also you share to me on this direction. Okay, this one I think that this one is not too difficult for you to understanding for the option A. Okay, option A is just that whichever that the customer provides, I will just forward between the AS to the other AS. All right. So that is how the option A is. So for option A, the step for the option A is what type of step that we have on the option A is. So step number one, they must have a basic IGP within the AS. Yeah, within the AS. So over here, you can running this as a OSPF, and the other side is running ISIS. It doesn't matter. As long as these two they are having the IGP connected, make sure that the PE can go to the ASPR, the ASPR can go to the PE. That's good enough already. That is the first requirement on the basic IGP. Second, basic MPLS within AS. Within the AS that I need to have enable MPLS. Okay, enable MPLS within your ASs. So far, okay? So that is on the second step. So you must have a IGP, you must have a MPLS. Then number three. So always you need to have a MPIBGP between PE and ASPR. Okay, PE and ASPR you must have a MPIBGP. IPVPN instance between PE, CE, ASPR to ASPR. So I need to build this VPN instance on this direction facing to CE, this direction facing to ASPR, this direction facing to the ASPR, and this direction facing to the CE. So that is what I require to perform. I require to define 4 different VPN instance. Okay, whichever inside here need to be matched. Okay, within the AS need to be matched. Right. And number 5, binding. Binding VPN instance. Okay. Number 6, form eBGP between PE to CE and ASPR to ASPR. We need to form the normal eBGP to learn the route between the customers and the providers, and also between the two providers we also need to run the eBGP. So that is on the step number 6. So actually the step for the option A, that's it. That simple step you need to be achieving for you to allow from one CE across multiple AS up to another CE. Okay. So far, right, this one on the option A itself. So under option A, do you have any question you want to ask or to clarify on the option A? Let's say there are no question, then I proceed to the option B. Okay, let's say you have no question on this. For binding the VPN instance over here, it's just to bind that when you bind this IP binding. The binding over here is to isolate routing tables. Okay. So when you're inside the VPN instance, you bind on the interface already. So it means that you're creating another routing tables already. So that is what it means on the binding VPN instance. Okay. So any other question other than that? All right. The tunnels. Okay. So the tunnels from here is let me just erase some of them for me to do a better better explanation here. So let me just remove this. So I'm going to include the tunnel information so to give you more ideas how it works. Okay. So from the tunnel information that need to be drawn in the option A, actually it be just similar into the traditional MPLS BGP VPN. So this is my V4. Okay. This is my V4 information from the CE to the CE. So that's a IP data. When they're up to the PE, so I'm going to add in the LDP and also the tunneling, the VPN labels. So VPN labels, if we start from here, up to the ASBR. And from this ASVR, go up to the PE. Okay, that is what they're providing over here. So this is my topper layers, a higher layer of the tunnels. That is on my MPS EBGP. Excuse me. And the upper layers is on my LDP. LDP is from this point up to PE, and from P up to ASBR. From ASBR up to the P, and P up to the PE. So this is on the outer labels. So it's from inner going and bigger up to the outer labels. Okay. Sorry. So means that in this case, within your traditional, normally this is how the traditional work. So you just combine the two traditional together. In between over here, it's just purely on the IPv4 traffic. This is just for the IPv4 traffic. Okay. When it's on the inner labels is your VPN labels, outer labels is your LDP labels. So you also can see that from this information, your tunnel labels, your VPN labels, you should have two different labels here. Okay. From here, you can using one label. It's called V1. But when going to another MPLS domain, you are going to using V2. They are not swapped. For the ASPR, they pop. Then for and the next ASPR, they push the labels in. So this information, they do not exchange. They do not exchange the VPN information. They only exchange the IPv4 information between the ASPR. It's just a route. Okay. When they go out and send to the CE, when I go out from this interface, I'm going to add on the V2 labels and also the LDP labels. Okay. So for option A until this is okay.
So, Nick,
Yes.
so there is no sort label, anything in this option A,
What label again?
not swipe process in this option
Yeah.
A. There is no
The
swipe
swap the swap process within the VPN label don't have, but for the LDP, yes.
for LDP. Okay,
Yes,
okay,
LDP they still swap from this to this, from this to this. They still will swap. Because from the P routers, they still swap.
okay,
Okay.
okay. Thank you.
Okay, so far for option A. Let's say I have no question from this option A, then I proceed to the option B, okay, and also option C later part. Okay, this is on the option A. Let's say you want, you can just capture the photo or capture your image, okay, to give you some understanding on this is how the option A is work, and the comparison with the option A. The next one I show over here is on the option B. Okay, so if it's same, I will just draw a small diagram here. So same things, you have a same environment here. But the difference over here is right now, this is still remain. This still remain. And right now, the only different things over here is, there's this thing. The only difference right now is between the ASPR1 and ASPR2. Instead of just IPv4 on the option A, on the option B right now, they shift to the MPE-BGP. Okay, they shift into the MPE-BGP. Means that they're going to exchange the VPN labels. They exchange the VPN labels from ASPR1 to ASPR2. They swap the VPN labels from one to the other one. So option A, let me just come back to this. Okay. So from this, you have two VPN labels. Okay. Push and pop. Okay. But in this option B, you have three VPN labels. You have push, swap, and pop. Okay. So they're going for push, swap, pop. So swap will be done by the ASPR1 and ASPR2. Okay. So in this option B, so what you need to know over here is between the MP eBGP. How we form the MPE BGP? So the MPE BGP is done between the ASPR1 and the ASPR2. Okay, that is where you define, okay, ASPR1 and ASPR2. The more important is between these two. The rest, you can see that they are the same. The rest, they are the same. All right. But from here, they have one thing you need to be aware under the option B. Under the option B, you need to be know what are the things a difference compared to option A's. So let me just go in through this way. So step number 1 for this option B, we need to have a basic AIGP within AS. Basic MPLS within the AS. So in this case, they're still the same, they split to 2. So they're going to have 2 AS in this case as well. Okay, AS 100 and AS 200. Okay, number 3. MP IBGP PE to ASBR. Okay. So between ASBR to ASBR, we have to enable MPLS as a basic for them to able to generating the labels. Let's say ASBR1, ASBR2 is not enabling MPLS. They are not able to creating or generating the route. Okay, they're not able to generating the route between the ASBR1 and ASBR2. All right, then number 3 is on the MP IBGP between PE and ASBR, and MP EBGP between the ASBR to ASBR. So this one, it can be just do it at the beginning. So between the ASBR, you can enable the MP EBGP as well. So between the PE and ASBR, you form the MP IBGP, and for ASBR to ASBR, you form the MP EBGP. And number 4 is doing the IP VPN instant. This VPN instant is different compared to option A. So this one is only between PE to CE. Okay, it just create an instant between PE and CE from one side and the other side. And number 5, binding the VPN instant. Okay, after binding on the VPN instant, what you required over here is between the CE and PE, they need to exchange the route information. They need to exchange route between CE1 and PE1. So I need to form the EBGP. Okay, so this is what is required. And number 7, on the ASBR or RR, you have to disable VPN target. Okay, this is what you need to disable. And the command is called undo policy VPN targets. Okay, that is what we include on the ASPR RR disable VPN targets. So actually the step over here compared to A, the till you undo policy VPN target, then only I can forward. Okay, let's say I want to transfer your information through the intermediate devices, you have to use this command, undo policy VPN target. That is a compulsory in the option B. In the option B, this is compulsory. And also, let's say you have route reflectors, then you also need to do the same thing as well on the route reflectors. Okay, and that is on the option B itself. And now let me just write it down on the tunnel information between the option B for between CE to CE. Okay, so between CE to CE, this is on the IPv4 itself. When IPv4, what we will have, I will have this. The first from the PE, PE1s, all the way up to the ASPR. From ASPR, swap and send to ASPR2. From ASPR2, swap and send to the PE2. So you see that's why I have said that they have 3 VPN labels in this case. And on top of this, I will have this information. That it will always fix. Okay, as a LDP information, the tunnel information. Okay, so maybe I can just Okay, that is how it looked like. So that's what we have from layer to another layers. So you can see that the outside layers is always your LDP. So from here, I push, swap, pop. Okay, push, swap, and pop. For the VPN labels, I push, swap, swap, and pop. Yeah, that is on the layers under the option B. So this is what I will going through. When first coming in, I push VPN labels and also push the LDP labels. And between the ASBR to ASBR, I swap the labels. And when they're up to the destination PE, I pop the labels. Is that right? For the option B. So far, this is the only difference that you need to be aware under option B. It's not a lot of changes compared to option A. Because option A, you do not have these two steps only. But right now, option B, you need to add on these two steps to make sure that there can be perform the forwarding on the MPLS labels. Is that okay up to this so far? Any question? Any questions on the option B? Is it clear on the option B before I proceed to the option C? All right. So then this is on the next one. The next one is on the option C, solution number one. And this is what we explained yesterday. Yeah, explained yesterday. So this one, you can consider the most complicated one is on the option C, solution number one. Okay. Because of in this case, they're going to on the option C, solution number one, they're using three labels. They're not only just VPN labels or the tunnel labels, they add on another label is called a BGP labels. A BGP LSP labels. Okay, let me draw it out. Option C, solution number one. So in the solution number one, let's say right now I'm going to just write it down like this. Instead of just PE, P, and ASBR, I add route reflectors. Okay, so the topology, I make it a slightly complex. So right now, I'm going to have this same things. Always, this is between this is always as a IPv4. Okay, it's always IPv4. Option B difference from option A on step 3 and 7 to make tunnel between ASPR1, ASPR2, and add one more labels. Yep, it's add one more VPN labels. Add one more labels between the ASPR1 and ASPR2. Add on the MPLS VPN labels. Okay, VPN labels will be add between the ASPR1 and ASPR2. Okay, this is IPv4 and LTP. Okay, so that is the things they added in on the option C. They have added in a core one as a BGP LSP. BGP LSP. That is what they added in. Is that all right? So they have a BGP LSP and multi-hop eBGP. Multi-hop MP eBGP. So you can see that totally different compared to option C. So under option B, they would just perform MP eBGP between ASPR. And now from here, I will have a MP eBGP. Sorry, I should have another one here. Okay, I should have an MP iBGP go up to the RR, between RR to the PE1, RR2 to the PE2. I still have an MP iBGP. So the connection relationship on the option C solution one, then it be more complex. So they add on more information in between the option C. So now the next thing over here, we need to know what we need to be aware when we perform the configuration changes over here. Because they added on a BGP LSP across the ASs. So right now from here, I have two AS. I have two AS. One AS is here and another AS. Okay. So let us just start from this first. Based on the option C solution number one, the step number one is as a basic IGP within AS. So the step number one and number two are always the same. A basic MPLS within AS and enables MPLS between ASBR. So you need to enable MPLS in between as well, between the ASBR. All right, up to this, okay, step number 2. So that is on the basic stuff we need to be defined first before I go further. All right, number 3. So number 3, have to make sure that order so IBGP and eBGP done within the AS and also between the AS. So it means that you need to form the IBGP connection between RR1 to PE1, RR1 to ASBR1, ASBR1 to ASBR2 need to form eBGP, ASBR2 to RR2, and PE2 need to form the IBGP. Okay, so all this pairing need to be done. The IBGP, IBGP, eBGP, IBGP, IBGP. The best, definitely P2 and P1 also involved as well. P1, P2 should be involved as a full mesh. So it means that all the devices inside your AS must have a BGP connectivity first. After you have connectivities, then only you can think of how to build the multi-hop MPE BGP. Okay, and step number 4, ASBR you advertise PE and RR route. Okay, so ASBR will advertise out my RR and the PE information to allow the PE2 RR2 know how to come back to PE1 and RR1. So they need to exchange the route information. They need to advertise the route between PE and RR. Okay, this need to be advertised out for them to know, oh, this is where they are going through. Is that okay? Up to this step. All right. After you're done on this step, when the ASBR has been advertising the route to the peers, the MP eBGP able to form the multi-hop MP eBGP. From the RR1 to RR2, it can be formed easily right now. Okay, so step number 5, MP IBGP between PE to RR. Multi-hop MP eBGP between RR to RR or PE to PE. So there are 2 options over here. And for the MP IBGP, you need to also be aware for this. You need to set this. Next hop in valuables. Next hop in valuables. What are the means of this next hop in valuables? So it means that when RR1 learn whichever come from PE1, when I send to RR2, by right, my next hop you change to my RR interface because I'm the one who sent to the eBGP. Okay, but because of right now that is inside this MPLS inter AS BGP VPN, I cannot change. The next hop must be still remain back to PE1. I cannot change my information. I need to remain as a PE1. So in this case, I need to add this command. It's called next hop in valuables. And also, I need to add another command. It's called undo policy VPN target. So this is what I required under the RR. RR facing to the PE1, I need to do the same things. And also facing to the eBGP, I also need to do the same things. The next hop, unavailables, and also undo policy VPN target. So this is need to be done. Okay, so far up to this on the MP IBGP and also multi-hop MP eBGP. So this one can be done only your IBGP and eBGP has been done. This need to be done before you can done on the multi-hop. So in this case, when you want to do this, you need to make sure that, okay, from here, you need to make sure from this. R1 can ping to RR2. So this one is just back to a normal IBGP and eBGP. Okay, so which when you from the eBGP, so from ASBR point to RR, you have to put the next hop locals. Okay, to say that whichever from ASBR sent to RR, the next hop is local because it's going to the eBGP. When eBGP sent to me, by right, this is the next hop interface. But after I forward to you, I'm going to say that, hey, I'm the one who the next hop you forwarded to ASBR 1 back to R1. Okay, that is what we need to perform. You need to grab the ideas. So far, okay? Under the option A, option C, up to this point. It's not finished yet, but make sure that over here you are clear before I move on. Okay, that is more into the like back to IGP. We need to make sure that PE1 and PE2 can talk, RR1 and RR2 can talk. Then only we can perform the MP IBGP and also the MP eBGP. It's okay. I proceed.
And so
Yes.
the step process between RR. Am I right?
What process?
our swap process in between RR or still happen in ASBR, ASBR, ASBR.
It means for the
Between
process of
RR1 to
the,
RR1,
yeah, the one, right? R1, right?
RR2.
R2. R1 and R2.
Yes.
R1, R1 and R2, they are forming the multi-hop eBGP.
Just routing. Okay.
Yep. They're using the multi-hop MP eBGP. So it means that when you define this, you need to specify this as well. eBGP max hop. Okay. At least you can calculate how many hop away from R1 to R2, 1 hop, 2 hop, 3 hop, 4 hop, 5 hop, loop back, it'd be 6 hop. So at least it'd be 6 and above.
Oh.
Okay, from the eBGP max hop. Need to be defined this.
So the function RR here is to make a prevent loops between or between P1 to between P on I on inter AS in AS 100 or AS 200.
It means for the R1, R2.
Yeah, the function R here is
The R in this environment is just that there is just one extra option that can be provided. If let's say in your AS, you have a lot of PE device, you need to define RR. Sorry, you are breaking. I can't clearly hear your question. Sorry, one more time. Hendrik.
yes, the function of the R here is different in option B is to prevent routing loop if there is a full mesh between PE1, PE to P1 or ASPR1.
Yep. So for option B, man, compared
There's
to
no
option
connection between PE1. Yeah.
Yep, the function between this option
Yes.
B and C, maybe let's say I will just go back like this. Let's say from here, they have no difference with RR, no RR on the option B. Let's say right now I add a RR from here. Okay. RR1. R2. They just have a LDP, LDP. And what you can have over here is the connection be slightly different like this. When you have a RR. So you just do like this. IBGP, IBGP, MP IBGP. Okay, just that because RR is just a route reflectors. So it's either you do the full mesh or you can do using a route reflectors. Just RR is the same function that just as a reflection. Whichever PE1 sent to me, I reflect to ASBR1. But the function on the option C, you can see that on RR2, RR1, they'll form the multi-hop eBGP between the RR. Okay, what is the added in? When compared to option B, they only have IBGP. They're not involved the eBGP. The eBGP, they're not using normal eBGP. They're just using the MP eBGP over here between ASBR 1 and 2. Okay, so they do not have IGP levels. They under the extended levels. They're just exchanging to creating the VPN labels. But the one that on the option C, they are creating the BGP LSP. Okay, they're creating BGP LSP. So this one is a slightly different. The layer encapsulation are different. Hendrik, did I answer your question, or let's say if not, can you just ask your question again? The function between RR and the option A, option B, and option C. Yes, Hendrik.
Yes. Yes.
Okay. I think your connection is breaking. But I can't fully hear you.
ABR.
Do you mind to type your question into the group chat? Because I think that the line is not good. I can't hear you clearly. Do you mind to just put your question into the group so I will know that what question you ask. Okay. All right. All right. All right. So let me continue from this point. So after this point on the MPI BGP has been done, then I will using the same step. I need to define the VPN instance. Okay, VPN instance between PE to C. Okay, as well as doing the binding as well. Binding the VPN instance. Number 7, CE and PE form the normal eBGP. eBGP between the CE and PE, from CE1 to PE1, PE2 to CE2, exchange the routes. So there one extra thing need to be done from here. I will write it down over here, number 8. Label route capability need to be enabled between PE to RR, RR to ASBR, ASBR to ASBR. So you need to enable all the related devices having these label route capabilities. This label route capabilities means that they can accept, they are enabling the BGP LSP. They allow on the BGP IPv4 labels. They add on another labels is called a BGP LSP by using the label route capabilities. They have these capabilities to support this. Okay, and number nine is to build two route policy. Policy number 1 for local AS to remote AS. Okay. From local send to remote AS, apply MPLS labels. This is inside the ASBR. Okay. Second, when remote send to locals, I will have a if match labels. I applied labels. Okay. So it will be on two directions. So when ASBR send to the next ASBR, the route information I send to you, I will build the MPLS labels. Same to this ASBR2, I will apply MPLS labels. So the other one is from the remote back to locals. When I receive these labels, I will go to if match. I create another labels back to the RR1. Okay, that is the two policy is required to define on the step number 9. So for this, you have more steps need to be defined on the option C, solution number 1. So far up to this is okay. All right. Let's say it's okay, then I'm going to draw it out, the tunnel information. This tunnel information is a bit more involved because they have involved 3 labels. So this one is depend on where the traffic is generated from. Let's say generated from this CE1 to the CE2. Okay. So first, I will know that how many labels they will have. Okay, I draw it out from the outer into the inners, so it'll be easier for me and be much better, nicer on the diagram. So I'm going to start based on the LDP first. Okay, that's my LDP. Okay, I write down the LDP first. So for LDP, they will not go to RR. Okay, LDP is just go for your best path. Your best path is from ASPR2 to P2 and the PE2. So that is where they are involving only. Okay. Okay, a bit too small, but it's all right. So this is on the BGP LSP. Okay, that's what I have on the second layers. Okay, but I can see that from the PE1 to ASPR1, they do not have any BGP LSP. Okay. So this is what I have. Okay. So they have an inner, outer, and middles. So that's why on this direction, that is how it works. So when you go to the ASPR out, you can see that you both cross another BGP LSP. Inside the BGP LSP, outer label is still have another LDP. So you can see that how many labels it cross. I have one inner is my data. This is my IPv4, and followed by this purple. That is my VPN labels. For this green colors, that is my BGP LSP, and the blue color is over here is my LDP. So in this case, I'm going to have three layers of headers on top of my IPv4. Only in this direction. When direction from the CE2 back to CE1, then you can see the BGP LSP from this point to this point to this point. Okay, that is on the option C, solution number 1. So this one is a bit complicated, but that is how it works. And as long as you grab the basic, it should be fine. Is it all right for this one? For the option C, solution number 1, is it okay on this explanation on how the option C solution 1, the principle it worked? So far, any questions? Before I go into the solution number 2, okay, let me just capture the attendance for this morning first. Okay. So up to this, it's all right. Before I go for the next one on the solution two, make sure you have ideas about this. Is that okay? For the option C, solution number one, is it clear right now? So that is the things that we need to be worried that what we're going to perform. So they have multiple steps on the option C, solution one, you need to be aware. So that is all the steps you need to perform, as in like this. Okay. So we need to have this information added in, need to be advertising the information, configure multi-hop eBGP, define the label route capabilities, and also build the route policy. So they have a lot of new things we need to be added in inside the option C solution number one compared to option A and option B. Okay, so I will just stop for a while. Let's take a break and come back. We continue with the solution number two. If let's say you have no question under solution number one, then we go for the solution number two. All right, so let's take a break right now. Let me just open up the slide. Okay, so we're back at around 10:50 and then continue with the solution number two. Okay, option C, solution number two. All right, let's take a break. So is everybody come back already? Shall we start? So that is on the option A, B, C, and solution number 1. And next, we look into the option C as well, but it's on the solution number 2. Okay. So that is on the Inter-AS MPLS BGP VPN option C. But this time it's on the solution number 2. So solution number 2 and number 1 is pretty similar. But from this, they just reduce the labels from 3 labels back into the 2 labels. Okay, just reducing the label information. So solution 2 is similar to solution 1, just that on the 3 labels, VPN, BGP, and tunnel LSP labels used in condition solution number 1, and 2 label is used in the solution number 2, VPN and tunnel labels only. So that is the thing. That is the one that they're going to be have differences from 3 labels to back to 2 different labels. So for solution number 1, a policy needs to be configured on the local ASPR to generate the new labels. You remember that just now I mentioned they're going to have 2 labels, 2 policy be created. Policy number 1 is for locals to remote. Number 2, when remote, back to locals. Okay. So after the local ASPR receive the labels of BGP route from the peer ASPR, the local ASPR located new labels to BGP route and advertised the route to the PE or RR. That is actually this what I mentioned here. Okay, that is what I mentioned from here, the 2 policy. When I advertise MPLS label to you, you can be also advertising to your RR by matching if match the labels that I built and send to the RR. So they need to have a 2 route policy. But for the option C solution number 2, MPLS need to be configured on the ASPR to allocate label to label BGP route on the PE in the same AS as the ASPR. You can see the LDP LSP to the peer PE instead of the BGP LSP. So this one is slightly different. They said that they're going to allocate labels of the BGP route. Instead of going to create the route and send the route into my peers, for the solution number 2 is only 1 policy needed. Just policy number 1. I will just need to have a locals to remote. Okay. When the remote AS receive this, they will based on the BGP route to do the labeling. Okay, the labels based on the BGP route that you are forwarding. So it means that right now the BGP LSP is only between the ASPR. So it means that for the solution number 2, PE, P, ASPR 1, ASPR 2, so something like this. So in between this is still running LDP, 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 LDP. In between running BGP. So in this case, the labels will be just like LDP, LDP, and ASPR they trigger whichever that you send from BGP. Trigger BGP route to create LSP. Okay, to create the LDP LSP and send to the P device. So P device will be based on what you advertise to me. I will know that what I should add it in inside my LDP section. So they're based on your BGP route information. Rather than just now, on the solution number 1, all the way after I receive, I'm generating a new BGP LSP, go to all the routers, go to the PE or go to the RR. But for solution number 2, they will just adapt this information under the LDP. LDP protocol, I add one command, is called LDP trigger BGP. I trigger the BGP route to define my LDP LSP path. Okay, that is what the differences compare solution 1 and solution 2. That is the only difference. But for configuration wise, then they have a huge difference based on solution 1 and solution 2. Because right now, I do not need to have a IBGP internally. I need to have a eBGP in between and just advertising that what I want to perform. Still the same. RR1, RR2 is still forming the multi-hop MP eBGP or the PE device. That's still the same. But just that the label generation are different right now. They're generating the labels are slightly different. So far, okay? For this or the concept under the solution number 2. Just give you ideas. Right now, the difference between solution 1 and 2 is one using 3 labels and solution number 2 using 2 labels. Okay, they're just using the VPN and the tunnels. BGP LSP is in the between, in the middles. Okay, that's something that is look like. Under the Inter AS and PLS BGP VPN solution 2, on the option C. So what we have over here is so from here what we have is first on the CE1. Sorry. So between this, let me just write down. They will have a IPv4 here. IPv4. It's still the same. From the PE1 all the way to the PE2, they're using the multi-hop MP eBGP. It's still remaining. Then the rest is just a LDP, 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 LDP. And in between ASBR, they're running the BGP LSP. Okay, up to this, is all right? And still the same things, when the MP BGP went from routers to set another routers, we need to make sure that the next hop is not been changed. Because going to eBGP, the next hop will be changed. So we need to do this as a next hop invaluables to say that I don't change my next hop before I send to you. Okay, so in this, just a BGP. You can see that they have extra this as a BGP LSP. Then they have a tunnel LSP and the VPN LSP and your IPv4. So BGP LSP is only between the ASBR 1 and 2. Whichever that you get into the AS200, they will automatically convert this to become tunnels. Tunnel LSP. So it means that from end to end, the label you can see is only 2 layers. Only 2 labels you can see. The first label is called the tunnels, and the other label is called VPN. Just that in between the ASBR, they are using the BGP LSP between the ASBR 1 and ASBR 2. Okay, they trigger the BGP route. Okay, to generating the LDP, LSP, and going across to this direction. Is that okay? So from here, let me just give you a better ideas. I will just add a single page from here and draw the diagram to show you that how it works. Okay, that's what we have. Okay. Okay, that's what the connectivity I should have inside the PE1 and also the PE2. Okay, so I'm going to form the multi-hop eBGP. Is it okay up to this so far? All right, so far okay? So let me write it down first. So there's a information they will have inside the option C, solution number 2. Is that okay? So based on this relationship, you can see that compared to solution number 1, I still need to form the IBGP internally, but right now it's not needed. I only form the eBGP between the ASPR1 and ASPR2. That's it. Okay. PE1 and ASPR1, they have no IBGP communication here. Okay, they do not have any IBGP connection over here. Is it okay? Okay, yeah. So in this case, next we look into this on the label information. Oops. Okay, never mind. Over here, I will just show you here. That is on the LDP. LDP information will be generated here, LDP. So in this case, LDP on the PE1, they will first generated the fact as a PE1, labels as a T1, as normal. When P1 receive, I will have a fact of PE1, label T2. When ASPR1 using the eBGP to forward this information out as a eBGP route, so I have a FE fact of PE1. Next hop, ASPR, labels, B1. Then for the ASPR receive, they'll convert back this into the LDP, fact PE1, labels, T3. And the fact PE1 from the P2 go to PE2 as a labels T4. This is one direction from here. Okay, this is on the direction from the CE1 go to the CE2. Okay, this is how they're advertising the route information. So far, this one is okay. So they're creating the labels of T3 and T4. So this is how they are going to perform the swap. So they have a push, swap, 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 pop. Okay. So they're going to go through a multi-layers here. But the over here is just one different things. It's called the BGP LSP here. Okay. It's a bit. Okay, never mind. I'm not sure how come what happened to this. I cannot erase for my information here. It seems it's not that stable into my PowerPoint. Okay, but never mind. Use back this color. By right, I'm using different color just now, right? I'm using a blue color and green color. But suddenly it just shifts to, is it all gone already? I think because of too many drawing over here already. It just bear with me a while. Let me just stop and open one more time. Let me just erase everything to make it smoother. Okay. I do a quick one because just now I just redraw a quick one. All right, this is the information I have. So far, okay. Shall we? I just redraw one more time. For this is for option C, solution number 2. Okay. Okay. So from here, I'm going to have this fact P1 labels T1. Okay, that is where I up to just now. And also the other way around, when this as a LTP on another direction, so I will have a fact of PE2 label as a T5 and T6. Then I have a fact of PE2. Next hop is ASBR2. Labels as B2. Fact is a PE2. So you can see that all the label information from source to destination, destination to source, it will be exchanged fully. So the tricky part over here is how they're going to be convert a BGP back to LDP, a BGP back to LDP. So we need to do it on the ASBR. ASBR is that LSP triggers BGP route. So by default, they did not trigger BGP route. Right now, you inform that, hey, I'm going to trigger my BGP route as well to perform the calculation. Okay, to perform a calculation, I need to together with this information. Is that okay? That is what I will involve. Okay, involve on the between the peers. Is that okay so far? Up to this point on the BGP part, the BGP LSP, do you have any question to ask before I move on? Okay, next. After this LDP done, the next thing is on the multi-hop eBGP. So this one, it be straightforward, it be the same. The only difference compared to solution 1 and solution 2, and this is the things, they're going to trigger the BGP packets. So for this, it be straightforward that what I have over here is from end to end. When IPv4 traffic coming in, I'm generating the BGP VPN v4 route. So with this information as a route distinguisher plus CE1 route. Next hop is go to the PE1. Labels as a V1. Okay. And on the other directions, from the CE2 sending this information out. Okay. From CE2 back to CE1. So we have a BGP, VPN v4 route as well. Okay. Route distinguisher plus CE2 route. Next hop, PE2. Labels, V2. So that is only the labels they've required from the solution number 2. So you can see that it's much simple compared to the solution number 1 for option C. You see that the complicated from solution 1 and the simplified version on the solution number 2. So they reduce the label information. Yeah, and the VPN label, you can see that they only have 1 labels. Okay, so you can see that first from the option A, they're going to use 2 labels. For option B, using 3 labels. And for option C, using only 1 VPN labels. So what I miss on the VPN labels, this one is only using 1 labels. So it will simplify the information here. Is it okay? Any questions so far? This one without the RR. With the RR, it be the same solution. Okay. Okay. All right. So option C is okay. Everybody. All right. So this is option C, solution 2, how they are changing labels. So the only things are different. This is the point. Okay, LSP trigger BGP route. To based on the BGP route to calculate your LSP labels. Okay, from PE1 they back to the fact PE1 and have a label of T3. So in this case, I will have push, swap, 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 pop, so on. So it means that when the traffic come across, okay, when the traffic come across, okay, when CE2 want to go to CE1, okay, first PE2, no, you want to go to CE1. First, I will add a label for you first. The label is called V1. Okay, there is a CE1 labels. Okay, CE1 route, I add label V1. My next hop is go to P1. So when I check P1, do you have a label for P1 for me to going out? Yes, I do. V1 is in my inner, outer is my T4. P2, you swap the T4 to T3 and send to the ASPR. V1, T3. Okay. When ASPR2 receive the T3, I will check, I'm going to map this back to the B1. Okay. From B1, they map into the T2. They swap to the T2. Then later, they swap back to the T1. When PE1 receive, remove, then I know that that is belong to the CE1. Okay, that is under entire process from how the traffic it be forwarding from end to the other end. Is okay? Any questions so far up to this point on the control plane and also how the forwarding is being done? Okay, then the next one we look into this. That is where the control plane design I explained. But this one, it be just showing you a one direction. The one that I showed just now is on the both direction. Okay, both directions on the LTP and also on the IPv4. Okay, so from here, they're showing you that from the PE1, you can see that all the while is all the PE1. The fact is all the PE1. All right. Okay, so that is on the control without route reflectors. With the route reflectors, it be the same as well. So actually, it's not a huge difference with the RR or without RR because the path, the calculation path are still the same. When you have a RR, the only difference when you have RR, you just need to define where is your MP BGP protocols. So because this one is still remain, the eBGP is still remain only between ASPR1 and ASPR2. Compared to solution number 1, they need to form the IBGP, but this one is not needed. From the option C solution number 2, they need to only have a MP IBGP, MP eBGP, and MP IBGP. That is what they required. Okay, this is what they required. So okay. This is on the control plane. Maybe I can just show you the slide compare back into the solution number 1. Let me just open the slide. So this is on the solution number 1. With the RR, you can see that I need to have a IBGP, IBGP, eBGP, IBGP, IBGP. Okay, but when compare this into this, they're only using the eBGP itself only. So do not require any IBGP in between. Is that right? Okay. So for the next one, this is on the forwarding plane. Under the forwarding plane, from the CE2 forwarding back this to the CE1, client 1. So this is what their process is being done. from client 1 data. So they have two labels. We have V1, we have T6, V1, T1. So you can see that it's very straightforward. The inner and the outer is keep on just pop, swap, and pop and swap. Yeah, actually, just from this PE, it just push twice. Then the rest is doing the swap, swapped, swap, and pop 2 times. Okay, push 2 times on the ingress, pop 2 times on the egress. So that is how simple it can be done on the inter AS BGP VPN. Option C, solution number 2. Yeah, the concept of the forwarding, is it okay? Based on the explanation that I did just now for this, is there any question that you want to ask me? Anything is not clear, please ask. Let's say if not clear on this, can you please ask? So in this case, I can give you more ideas on that. No question? All right. So let's have a look on the second part from here. It's on the features of the inter AS MPLS BGP VPN option C. So when compare back to option A and B, so what's the difference between option C? VPN route are directly exchanged between the ingress PE and the egress PE, and the route do not need to be stored or forwarded by the intermediate devices. They do not need to keep and forward. What they need, they will just as a transparent to them, just as a transparent, because of I form the MP eBGP from the RR to RR or the PE to PE. Whichever that I send, the router behind, they are not aware of this information. But for them to able to forward my LSP and the BGP LSP need to be formed for us to know on the both end, the both PE devices. Okay, only PE exchange VPN routing information, whereas P and ASPR only forwarded packet. They just forward packet, they do not know what they are forwarding. Okay, they're just forwarding the packet out from their interface. That's it. Is it okay? And the intermediate device only need to support MPLS forwarding instead of VPN services. It means that they just need to have a basic MPLS, the basic stuff, but they do not need to go up to the VPN layers. And therefore, ASPR are no longer a bottleneck. Option C is suitable for the VPN that span to the multiple ASs. When multiple ASs, that will be the good option on the option C that can be used. Okay, when you're going to be interconnect multiple ASs. Okay, multiple ASs, that is a good tools for us to perform. Is that okay? All right. Then the VPN load balancing is easy to carry out into the option C because it's direct from the RR go to RR. So load balancing will be easier. Let's say you have multiple way between the two RR. So let's say a multiple way is good, easily defined on the load balancing. And the disadvantage of this mode is that the cost is too much to manage and end-to-end connection between the PE. So the main things, the most cost affected will be on the end-to-end, the PE to PE, RR to RR, the path, and also the device between that two devices will be very powerful to handling all this information. That will be just the small drawback into this, the disadvantage. The cost is very high to manage the end-to-end. Okay, So that is on the option C, solution number 2. And now we look into the step-by-step we need to be done under option C, solution number 2. Okay, so let me just bring up this. Go to the solution number 2, configurations. Okay, option C, solution 2, configuration. Under this solution 2 configuration here, so it's the same topology that we have earlier on. So with the RR1, RR2, adding the RR. So actually the configuration will be pretty similar, just have some of the different changes here. So first, that is pretty normal. Define IP addresses. Okay, define IP addresses. Configure OSPF. This is on the basic IGP. Within your ASs. That is on the basic MPLS. Configure MPLS, LDP, PEP, ASPR over the public network. Then followed by the eBGP between ASPR. Okay, ASPR to ASPR. So in this case, configure ASPR to advertise the route to the loopback interface of the local RR and import the route to the IGP process. Okay, that need to be, because let's say you do not do this, your multi-hop MP BGP is not working, because they still need to know each other, need to be really eBGP. So that's why we need to do the import route. Okay, import route. Number 5, configure VPN instance. This is on the VRF. Binding and configure the VPN instance on each PE. Configure peers, eBGP peers. This eBGP between PE to CE. And this is on the multi-hop, MP, eBGP, and also MP, iBGP on step number 8. Okay, that what need to be done. Okay. Number 9, enable the capabilities of exchange labels IPv4 route between ASPR. So right now, this label route capabilities do not need to be all the routers. It's only between the ASPR only. Okay, to make sure that they can able to exchange the BGP LSP labels. Because right now, this is only between the ASPR running BGP LSP. After that, they're just using the LDP LSP. So it's not required on that. And number 10, on each of the ASPR, enable LDP to allocate label to the labels BGP public network route. So this is what I mentioned. That is what needs to be triggered. LSP trigger BGP label route. So when you have a BGP LSP, I trigger this and create your LDP LSP labels. So that is what the main focus inside the solution to reduce the labels by using this LSP trigger BGP labels route. Is it okay? And step 11 is apply a route policy to the route to advertise the local ASPR to remote. So only one policy required. Okay, one policy required from the local to peers. So it means that it's just a policy number 1, just to apply MPLS labels. Is it okay? So you can see that they reduce some of the information compared to what we have inside the solution number 1. Okay, slightly reduce. The configuration reduce. Is that okay? So based on the remark here, enable MPLS on the ASPR1 and ASPR2. LDP is optional. Actually, LDP is not need. No LDP required because in between they're running the BGP protocols. There is no need to configure VPN instant or binding between ASPR1 and ASPR2. That is same as the option B. Option C, they do not need to build the VRF. Configure ASPR1 and ASPR2 exchange label IPv4 route with each other. So they need to do the labels, route capabilities. Okay. Ensure that local RR does not change the next hop of the VPN route when advertising them to the remote RR. Also, ensure that the remote RR does not change the next hop of receiving VPN route when advertising to the PE in the same AS. So this is what we need to define. We need to set that next hop invaluables. Okay. Configure a route policy on ASPR1, ASPR2 to allocate the labels. As I mentioned, policy 1 apply MPLS labels. And on each ASPR, enable LDP to allocate label to label BGP public network route. Okay, that is on the LSP trigger BGP route. And from this, it's not only this, we also need to set that next hop inavailables and also undo policy VPN target at the route reflectors. RR need to do this. Route reflector need to do this. Is that okay? So far, questions from here? So this is on a step by step, in total 11 steps. But definitely we can reduce all those steps. And let's say they have no question on this step. Let us doing the lab together. All right. So let me just share you this. Yeah, this one is a Inter AS VPN option C2. All right. So have you downloaded and start the lab. So let me know after you started, so we can define this together on the last lab. So far, all right, up to this. Then I'm going to start to configure the. So it's all for you with me. So can I proceed? Is there everything started already? All right, so I'm going to get start from the PE1 all the way up to the PE2. So to perform, I think this, I do not have created anything yet, only IP addresses. So it means that it's the same step that you're doing about the fourth time right now. So I think that by right now, you should have no issue to define on the MPLS basic and also the VPN instance. But over here, it's just something to be aware that there's slightly difference that we need to be aware. So it means that how we're going to form the eBGP between the ASBR, how we set the triggers, how we set the local label route capabilities, and how we set the undo VPN and set the next hop inavailable. So this information you might need to just be careful when you configure this. So I will start to configure on the step number 1 on the define MPLS. Okay, so I do the quick one from here. So you can follow. Do you want me to put it to the notepad? Yes, Hendrik?
Yes, you can write down on the notepad first, sir.
Okay, sure.
Thank you.
Thank you. Okay, let's say you can't copy, you just refer back to the notepad. Okay. So from this point, I also enable the MPLS together between ASBR 1 and 2. Okay, ASBR 1 and 2. Or you can do it later part. It's better to do it later part to make sure that you are clear step by step. Okay, I do it on later part. So I've done on all the devices already. Okay, from router number PE1 up to the PE2. All the device internally, I have a basic MPLS has been defined already. Is it okay? All right. So for this is on the PE configuration. Second step, after we've done this, we define on the BGP protocols. So on the solution number 1, we need to form the IBGP and also eBGP. But for the solution number 2, over here, we only need to form the eBGP in between the ASPR1 and ASPR2. So I go into the ASPR. Step number 2, eBGP between ASPR. So from here, that's what I'm be done. BGP 100 from the eBGP peers first. Peer 10.0.34.4 AS numbers 200. Okay, then followed by IPv4 family unicast network 11.11.11.11.32. Okay, 11.11.11.11.32. First imported first. So after this, one more network 1.1.1.32. Advertise both your RR and the PE. Let's say you PE to PE, just advertise PE. Let's say you have RR and PE, you need to advertise both. Okay, for a later can be data communication, that is a requirement. Okay, they require on this. Is that right so far? Okay. Then go to the, before that, I need to do this. Import route. Sorry, not import route, BGP. I need to go to the BGP. So OSPF1, import route BGP. Whichever that I advertise into the ASPR, import to the OSPF. Okay, so at least that whichever I advertise, my P1 RR1 will low. So I do not need to form the IBGP. So whichever I advertise that I learned from ASPR2. So I will do the same step. Let me just copy this. Okay. So for ASBR2, BGP 200, peer 10.034.3, then I will go to the IPv4 family, unicast. Network 22.22.22.22.32, and network 6.6.6.22. OSPF1, import route BGP. So whichever you learn from BGP, import to the OSPF. Display OSPF route. Just give a moment. Let my BGP peer eBGP up. Display BGP routing tables. 1611.22. Display IP route protocol OSPF. Okay, I learned 22 already. Twenty-two. Hold on. 6.6, 22. Import BGP. Okay. So on the RRP2, PE2, right now I learned this 11.11 and 1.1.1 from externals coming into me, where I import BGP route into OSPF. So that's the result that what we want to get for 1.1 and 11.11.11. Okay. From ASBR2, the configuration over here, let me just copy this to here. Okay. So that is on the step number 2. Is that okay? So this eBGP between the ASVR and also the route importing between route import one direction from whichever BGP that you learn, import to IGP. That is meant for us to define the MP IBGP, MP eBGP, multi-hop between RR1 to RR2. Okay, that is what the meanings from this. That is on the step number 3, step number 2. And number 3, we need to do the basic step of the configure VPN instances. Configure VPN instance. That is the normal things that we did most of the times. So from here, I said that is on the VPN instance. Yeah, VPN instance. So from PE1, I configure one instance. VPN A and route distinguisher 100:1 VPN target 100:1 both. Okay, that's it. This one is the basic that we did most of the time, and the PE2 as well. IP VPN instance VPN A route distinguisher 100:1 VPN target 100:1 for both. All right, that is just to creating the VPN target. Number 4 is on the binding VPN instance. Okay, to bind the VPN instance, you need to know which interface that you're referring to. So it's go to the interface gate 001, displays, okay, interface gate 001, display this. This is my IP address, 10.0.17.1. So I perform this. I to perform the IP binding, VPN instant, VPN A, IP address 10.0.17.1.24. That is on the PE1. And from PE2, you're doing the same step as well. I go into the interface gate 001, display this, and IP binding, VPN instant, VPN A, IP address 10.0.68.6.24. All right, that is on the configuration I perform under the step number 7, number 6 to do the binding as a number 4 over here. Let's say refer back to this. That is on the step number 6, binding. And step number 7 is just to doing the eBGP between the peers. eBGP between the peers. All right. So I'm going to define under my first, go to CE1 first. CE1, same thing, 65,000, peer 10.0.17.1, AS numbers 100, IPv4 family unicast, network 777.32. Okay, this is what I require to do on the CE1. Step number 5 here, doing the eBGP between PE and CE. This is from the CE part. CE1 to PE1. So from PE1, BGP 100, IPv4, family, VPN instant, VPN A, peer to 10.0.17.7, AS numbers 65,000. Okay. And from CE2, BGP 65,001, peer 10.0.68.6, AS numbers 200, IPv4, family, unicast, network 8.8.8, 32. And from PE2, you have to learn the information, BGP 200, IPv4 family, VPN instance, VPN A, peer 10.0.68.8, AS numbers 65,001. Okay, so this is step number 5 to form the peering between the PE and the CE. It's okay up to this point so far? Can still follow? Okay, yeah. So far up to this point, is everything is still okay? Still can follow? Then the next one we are referring to this as a MP-eBGP, MP-iBGP, MP-iBGP, and disable each RR from changing next hop to the route being to the advertisement. So that will be a long configuration for this. So just follow a step by step from here, sir. So for this one is step number 6, MP-iBGP, MP or multi-hop, MP-eBGP. Disables next hop change. All right, so I'm going to do it slowly, one by one. First, I do it on the PE1. Okay, from PE1, I need to form the MP-iBGP between PE1 and RR1 first. So I'm going to have BGP 100 peer to 11, 11, 11, 11, AS numbers 100. So using loopback, you need to do one more round. Okay. Okay. This is what need to be done on the PE1. It sounds simple here. Okay. There is a step. The first step between PE1 to RR1. BGP 100. Peer 1111. AS number 100. Peer 1111. Interface loopback 0. IPv4 family. VPN v4. Peer 1111 and enables. Peer 1111. Next hop in valuables. It's okay up to this point. Okay, and also on the RR, you also need to add one more: undo policy VPN targets. Okay, this is on the MP-iBGP. MP-iBGP. So I configure MP-iBGP first, then only show the MP-eBGP. So maybe I will just remove this. Display next hop change and also undo the policy. So next, I do it on the PE2. BGP 200. Peer 22, 22, 22, 22. And R2. Okay, so R2. Okay, that is the things need to be defined here. All right. Then this is, I make it as a 6.1. 6-2 is a multi-hop MP eBGP. Okay, so between RR1 and RR2. So between RR1 and RR2, first BGP 100, peer to 22, 22, 22, 22, AS numbers 200, peer 22, 22, 22, 22, back zeroed. Okay, peer 22, 22, 22, 22, eBGP max hopped 8. Okay, IPv4 family VPN v4 peer 22, 22, 22, 22 enables peer 22, 22, 22, 22 next hop in valuables. So this configuration on the RR1s. So before you're doing this, you have to make sure that from RR1 and RR2 can ping in between. So I can set that, let's try to ping minus A 22, 22, 22, 22 to 11, 11, 11, 11. So make sure this can be done before you can form the peers. Let's say this is not there, the peer you will never up. Okay, this is a basic requirement here. So this is where I perform just now. When I perform on the step number 2, I import route. Yeah, I import route. That is where and how I can be pinged between these two devices. Okay, so I've continued with this on the multi-hop MP BGP. So 200 peer okay, then peer 11, 11, 11, 11 eBGP max hop 8 hopped. Okay, IPv4 family VPN v4 peer 11, 11, 11, 11 enables peer 11, 11, 11, 11 and next hop in valuables. Okay, this is on the RR2. That's all the configuration need to be done on these sections. Okay, so just wait for a while to make sure that the peer is up and running. Maybe I can check on my RR1 first. Hold on, someone asked. So the max hop, I just put a limit. Actually, from my case, 6 and above. So I will just put 1 or 2 hop extra because of from RR1 to RR2. So 1 hop, 2 hop, 3 hop, 4 hop, 5 hop. Loop back is 6 hop. By right, it should be up to 6 hop. Okay, 6 hop. Or you can also doing this way to test it out. You can do a tracer minus A from 22, 22, 22, 22 to 11, 11, 11, 11. So over here, it is just setting is a 5 hop from dot 5, dot 4, dot 3, dot 2, and dot 11. Don't forget your loop back as 1 hop as well. So actually it's 6 hop. So I make it some buffer, I just set as an 8. But the minimum is 6. Okay. So I just put hop of 8. But it can be any numbers. Anything's numbers is more than 6. Is it okay? Jackson? Jason? Yeah, Jackson. All right. So that's where we can define where is my eBGP max hop. And now let me just double check display BGP VPN v4 or peers. So make sure that the peer is established and running. Okay. From R2 go to 11, 11, 11. right now that is in established state. It's up and running. It's okay. And next step, the next step over here is, sorry, they call as enable the label route capabilities. Okay, this one is straightforward. So let me just open up this. Okay, enable the label route capabilities between ASPR. Only between ASPR. So it means that I go to the ASPR here. Okay, on the ASPR, this is what I need to define. BGP 100. Okay, I just do a peers 10.0.34.4 and labels route capabilities. ASPR2, BGP 200, peer 10.0.34.3, labels route capabilities. So this is just to support the BGP LSP, this command. Because the BGP LSP is only run between these two. So that is only two configuration under ASPR. All right. And step number 8 is to trigger your BGP labels route. Okay. So using the LSP triggers. So this is also between the ASPR1 and ASPR2. So this is how we perform MPLS, LSP, trigger. So they have a trigger of all BGP label route, host, IP prefix, and none. So we are going to trigger the BGP labels route. Yeah, this is what we're going to be enables under number 1. Same to the ASPR2. MPLS, LSP, triggers, BGP, labels, route. Yeah, this is what we need to be added in under ASPR2. Number 9, policy to apply MPLS labels. From the ASPR, go to remote AS. Okay, from the ASPR, go to remote AS. So I also do it on the ASPR as well. Okay, so from here, this is how I define it. And also enable MPLS between ASPR. Okay, build the policy and also enable the MPLS between the interface. Gig 000 MPLS enables, and then route policy P1 permit node 10 apply MPLS labels. BGP 100 peer 10.0.34.4 route policy P1 export. Okay, whichever I export out, I'm going to set the labels. That is on the question number 9. On the policy, applied labels and also enable the MPLS between the ASPR interface. So I do that on the ASPR2. Okay, interface gate 000 MPLS. Route policy P1 permit node 10 applied MPLS labels. BGP 200 peer 10.0.34.3 route policy P1 export. So this is what I need on the ASPR2. Okay, that's all. After this, you should see that CE1, CE2 should receive the route already. It's not receiving yet. Seven and 8. Okay, so you see it's learned already, sir. Display IP route. It's run the 7.7 and my direct is 8.8. My direct is 7.7 and learn 8.8. So white cursor has been learned. So that is on the step-by-step under the option C, solution number 2. Let me save it first for you to have a reference. Okay, so I will save this information and send you the copy. Okay, and that's all for this on the Inter-AS VPN options C2. All right, so at the moment, let's take our lunch time. Come back, I will just round up summary a bit before we go for the next topic. Okay, let's go for the lunch, 1 hour.